So this is the, let me scroll up. This is the agenda. Yeah. So as you know, the equation of straight line is equal to y is equal to mx plus c, right? And we have already discussed extensively in the last class. Here m is nothing but my slope, c is nothing but my intercept, x is nothing but my independent variable, and y is nothing but my dependent variable at all. Dependent variable at all. Clear, guys? Now, if I fit a real world problem statement like how I have said in the last class, then generally I have indicated that y is nothing but my price which I need to find out is equal to m is nothing but slope again, let it be, x is nothing but my area which is already given, and c is nothing but y plus, correct? So now here what is area? Area is nothing but my feature. Price is nothing but my target value. Yes or no? Now here guys, as it's the equation of a straight line that I'm explaining about SLR, simple linear regression. That's why you can see here y depends upon only one variable that is called x. But in today's class, I'll show you that is MLR, multiple linear regression. Whenever I want to predict the price of a house, it does not depend upon only area. It depends upon different factors. Think about it in the real time. Generally, for example, you want to purchase a house. Do you think that only the house price of the house depends upon only the square feet area? No, it depends upon area. It depends upon BHK. Like there is number of bedroom, number of BHK. I can say BHK. Okay. Then, for example, location also matter. Location, and I can say how old sorry, how old that particular building is or house is, how old that house is. If it is newly constructed, let's say 1 year, 2 year, then price will be definitely little bit high. If it is let's say 10 years old house, 15 years old house, you want to resell it, then obviously the price will be less, right? So it depends upon like not only these three, lot of things, lot of let's say it depends in tier 1 city or tier 2 city and all. So it depends upon different component. Let's say tier 1 city location, basically tier 1 city or tier 2 city, and all. So depends upon different city, different location. The price value depends. Now in this case, it won't comes under simple linear regression. It comes under multiple linear regression. Now in the last class, I have given a glance what should be the equation of multiple linear regression for a straight line. If I draw the same straight line, the equation of multiple linear regression, I can say y is equal to m1 x1 plus m2 x2 plus m3 x3 plus dot 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 plus mn xn plus c. Okay, I can say, let's say this is equation number 2. Equation number 2. Guys, it's very simple. Instead of just writing only one parameter, that is mx, it depends upon multiple parameter. Okay, so what I'll do here now, think about the condition is, okay, condition is, let's say all the slopes are same. So what is m1, m2, m3? All the slopes. Let's say m1 is equal to m2 is equal to m3 and so on. If that is the case, mn, then I can write one common parameter, let's say m. So I can put m in place of m1, m2, m3 and all. Then I can rewrite this equation, that is y is equal to m into x1 plus m into x2 plus m into x3 plus dot dot dot, m into xn plus. Now guys, m is common. Can I common parameter? Can I take common m, that is x1 plus x2 plus x3 plus dot 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 xn plus. Now this is same as if you consider this same as the first equation. No? Just instead of x, it depends upon different independent variables. So I can say this is my x dot, this is my independent variable, and obviously this is my dependent variable, and this is nothing but my slope. I know, and this is my intercept. See how beautiful. Same things I have written here, right? Independent variable, dependent variable, slope, and intercept. The thing is that in simple linear regression depends upon only one independent variable, but in multiple linear regression, it depends upon multiple independent variables. Then if I give a node, then what is the difference actually? Node. Let's say, okay, 1 minute. Let's say SLR, simple linear regression, multiple linear regression. This is one variable. So this is my, let's say, dependent variable, that is y dot. Okay, this is my independent variable, that is x dot. Okay, so if I want to fill the value dependent variable for in case of SLR, that is 1, that is y 1, MLR also 1. In independent variable SLR, it's 1, but it is more than 2. See, more than 2. If it is 1, it is SLR. If it is 2 or more than 2, 2 or more than 2, then it comes under MLR, multiple linear regression. That is the key concept, I can say, behind simple linear regression and multiple linear regression. Now, let me derive one more thing. Now, here I have taken, this is a condition, provided all life slope m1, m2, m3 are same. Let's say this is a condition. Then, for example, this is not the same. What will the equation? The equation will be y is equal to m1 x1 plus m2 x2 plus m3 x3 and so on, which I have already written, mn plus normal, like this one. Which one? This one. Which I have written. Now, let's say for example, in our equation, in our discussion, so to make it simple, I don't want to take multiple feature value, that is 10 feature value, 20 feature value. Let me take either 2 or more than 2. Let me consider 3 feature value. One is area, one is, let's say, a number of BHK, oldness of the house. So these 3 value I will consider my feature value. Now, can I just modify this equation y is equal to just three term I will take m1 x1 plus m2 x2 plus m3 x3 plus c because I am considering only three feature value. What is m1 slope 1? What is m2 slope 2? What is m3 slope 3? Now, can I map it? So this is my price is equal to m1 into x1. I can put area plus m2 multiply with let's say number of BHK plus m3 into oldness of the house, oldness of the house plus c. Getting my point, guys? Now what I'll do, obviously, like in the last class, what I have done, like for example, I need to predict, okay, price of the house. So area is giving, BHK, 3 bedroom is giving, 40 years old. This three thing is giving. So I will implement everything. Obviously, data set will be given. I will show you when we will enter into the practicals. Okay. Then my model will decide some value. Now my model will decide some price value. Now in this equation, this is my final equation. Let's say equation number 3. In this equation, I will put area which is already given. That is 3000. I hope. Yeah. Then bedroom 3. Then 40 years old. Now I will predict M1, M2, M3 value, like how I have predicted in the last time. So M1 is nothing but slope, or I can say coefficient or gradient. This is the different name of the slope. Then what is C? It is intercept. So I know how to find it, very simple. For that, what I'll do, just let me give a quick recap if you have forget. So obviously I'm creating the object of the linear regression. REG is equal to linear regression, right? Then I'm fitting my model. Basically, I'm training my model. REG.fit. I'm passing x train, y train. And from where I will get x train and y train, I will split my entire data into 70:30 ratio, right? I already explained. Anyway, I'll explain one more time today. Then once I'll do, then you know REG dot COEF coefficient. If I write this thing inside my print statement, then it will give me what are the value I will get. That's nothing but my M1, M2, and M3 value. Because three stuff I will get, right? M1, M2, M3. So it will give me three value. Then how to get coefficient value? REG dot coefficient, COE, sorry, intercept underscore. Then it will give me what are the value I will get. That's nothing but my C value. Now I got my C value, I got my M1, M2, M3 value, right? And I know area, number of BHK and oldness. If I put everything, every value of this particular variable, then happily I can get price. Now what a price value I will get by doing the manual calculation, I will try to match it, whether it is matching with the price that is predicted or detected by the machine learning algorithm or not. If both are same, then I can say my model is 100% accuracy. If there is something here and there not perfectly matching, then I can say my model is not 100% accurate. There is something biased towards some data set and all. Clear? Like how we have done the proof and all. That also everything I'll do as part of my today's class. Proof. Everything I'll do. Okay. So before proceeding, let's go some theoretical aspect, try to understand what is this multiple linear regression and all. Okay. So let's start with the first one. That is motivation where one variable is not enough. Okay. Anyhow, I have already explained as part of my discussion, but officially let me show you some slide, and you can get much better idea. Motivation when one variable is not enough. Okay, let me share my PPT, guys. Okay, now you can see this is another example by knowingly I have taken because I know while doing the practical hands-on I am doing the house price prediction. Similarly, in the slide while explaining, I have taken another example that is sales of a particular product. Now, guys, sales of a particular whenever you want to sell one product, you might know there are a lot of advertisements going on. Okay, generally, uh, 15 years, 20 years before, people are using this platform as a advertisement platform. That is newspaper, radio, TV ads, sometimes that poster, hoardings and all. You might have seen while going on the road, a big hoarding they are just putting on the road side of the road and all. So that people can see it. They will get the knowledge about that product, what is this product all about. Then try to search it and they will get. Now, last even 10 to 15 years, as social media is booming. So instead of using, obviously they are using this platform. I'm not denying that, but in addition to that, they're using some different social media platform like let's say YouTube, Instagram, let's say Facebook page, LinkedIn, okay, to somehow Twitter also, like different social media platform they are using. Now, sales of a particular product does not depends upon only one platform. You can see it's written TV. You cannot say the sales percentage of the revenue that I'm generating in a month or a year, that does not depends upon only TV. I mean, the ads that I'm running on TV. No, depends upon radio also, depends upon newspaper also, and in addition to that, depends upon different social media platform also. So now, this is the best example of multiple linear regression. You cannot include such type of program statement under simple linear regression. Why? Because sales of a particular product does not depend upon only one platform. Otherwise, people can stay in any one of the platform. Let's say, for example, they are running the ad in TV. They may tell, I mean, company may tell, okay, I'm running ad in TV. Then what is the use of using, let's say, YouTube? Because they have to run the Google ad or YouTube ads, right? For that, they have to pay. It's not free of cost. Then why they are spending lot of money in the marketing campaign and all? Just to figure it out because they know all the people are the same people is not present in different platforms. For example, let's say I like let's say YouTube because I'm looking for technical video and all, or maybe I have a platform of LinkedIn, but I don't want to waste time in Facebook, so I don't have any account in Facebook. Let's say for example. So if any product is selling Facebook, I cannot get any information because I never log in the Facebook from last 10 years. For example, a person like Facebook, but they don't like Insta or they don't have account in LinkedIn. For example, a particular product is running, the ads is running on Insta or LinkedIn. Obviously, they cannot get the information. So it's better to present all the product their presence in all different platforms so that anyone out of this platform, anyone if you have, then happily you can get the information about that. Are you getting my point? So that is the best example of multiple linear regression. You can see, and obviously depends on is finding out the different revenue and all. You can see if they are considering a TB plus newspaper. Let's say for example, they are doing a profit margin of 0.83. I mean 83%. But whenever it combined TV plus radio, is becoming 91% sales or maybe revenue. If I add all three, maybe TV plus radio plus newspaper, it may go up to 95%. Are you getting me a point? That's how. If I will consider only one, let's say only, for example, let's say TV, you can see 81%, 81.6. Only radio, 11.2. Only newspaper, even if, not even, 5.8%. Very small, very less. Getting my point? So that's why always company they prefer to their presence, I can say virtual presence in all different platforms to sell a particular product. Okay, now let's move to the next one. Okay, what is the motivation when one variable is not enough? Just now I explained because the percentage you can see is very less. But if you combine all different platforms, the percentage is keep on increasing. Okay, that is the motivation behind it. Now, this equation I have already explained. No need to spend much time, right? Y is equal to. So they have generally, as you know, in the last class I told you, we are using M and C. So in the books or maybe in the different notation, they are using beta 0 and beta 1. Think about beta 0, nothing but C, intercept, and beta 1, beta 2, beta 3, P is nothing but kind of M1, M2, M3 and all. Then you can see X1, X2 and all. Okay, fine. Now, there is a concept of multicollinearity. Okay, I'll explain what is that multicollinearity and how to find out that one. Okay. Yeah. Now, let me come. Yeah. So guys, okay. Like as I told you, whenever I'm extracting the data from source system, let's say in the real time, I've seen in one table 112 columns are there. Have you imagined? 112 columns are there whenever we extract the data from one table. Some table may contain 48 columns. Some table may contain 76 columns. Do you think that guys all the columnary data are required for my further analysis? No. Maybe out of 48 columns, I require only 12 to 16 columns or maybe 20 columns. Then what's about the rest of the column which is not important? I need to drop. I need to delete those columns. I don't need to forward those column values for my further analysis, otherwise it will occupy memory unnecessary. Then how do I know, sir? Out of 48 columns or 76 columns or 100 columns, which columns are important for me? Which columns are not important for me that I need to drop? How to find out? There is a concept called multicollinearity. It's mentioned here. To deal with the multicollinearity, just let me maximize it. The following method can be employed. What is that? Removing variable. One way to address multicollinearity is to eliminate the variable that is highly correlated with others, or to choose the one that is more interpretable from a business standpoint. Now, creating new variable. Another option is to generate a new variable by combining the existing one. This can be done by adding interaction feature which are derived from some of the original feature. Now, variable transformation, multicollinearity can also be addressed through variable transformation such as principal component analysis, which will be covered in the latter module. Fine. So let me explain all these 3 points in my whiteboard. Then we'll get a better understanding. Okay. Let me come back to my whiteboard. Yeah. Yes, I will remember in the last class I have told you, okay, now the question is how do I know which columns I need to drop it, which columns I want to drop it. I have explained in the last class there is a statistical modeling value that is called p value. I will remember p value. So we need to find out the p value of a particular column. And as you know, so what is the standard value or the threshold value of p value is nothing but 0.05. Yes, sir. If my p value of a particular column, p value of a particular column is less than or equal to 0.05, then I will consider that column. Means I have to accept the null hypothesis, or I can say consider those columns. Why? Those columns show value evidence. Those columns having significant contribution toward deciding the target variable. If my p value, if my p value okay, if my p value is greater than 0.05, then reject or don't consider, reject those column value, reject those column value. As simple as that. This is a statistical modeling value. Based on, obviously, I mean, a lot of other things are there. I don't want to make it too much complex. Okay. So this is one of the simplest way. So if you consider this, then you can decide which column value I need to figure it out, which column value I should have to reject. This is the one, first condition. Second one, because 3 point we discuss. Second point is guys, let me take a data set. For example, this is a employee data set EMPLY employee dot CSV employee dot CSV. Okay, fine. Let's say this is my employee ID, employee name. Just 1 minute, guys. Just 1 minute. Let me put my charger. It's going to end. Soon just 1 minute. Let me push my charger. Okay, fine, guys. Yeah. So employee ID, employee name. So let's say salary, and see, let's say address. So these are the columns. So let me take few values. That is, let's say employee ID 1, 2, 3, 4. Name is called, let's say whatever name, X, Y, Z, A, B, C, P, Q, R, X, Y, Z, A, B, C, P, Q, R, A, N, O. The employee salary, for example, let's say, just for short purpose, let's say 1,000, 2,000, 2,500, 3,000. Make sense? Now address, let's say Bangalore, Chennai, Hyderabad, Delhi. Clear? Now what will happen, guys? So I have this data set. For example, it contains lakhs of row. I have 4 columns and all, right? So what I'll do? So I'm giving some kind of, let's say, bonus. Okay, this is my original data. This one. So to give bonus, I have added a new column called, let's say, bonus. I'm giving some festival tips to them. Okay, festival tips to them. For example, I'm giving bonus. Let's say this is around 250. This is around, let's say, 300. This is, let's say, 400, and this is, let's say, 500. Now I'll find out the total gross salary. Gross salary. Now gross salary will be combination of both the two. So 1,000 to 250. This is 1,250. Now this is 2,300. Then this will be 2,900. Then this will be 3,500. Yes or no, guys? Now tell me, initially in my data set, I have only 4 columns related data was there. Employee ID, employee name, e-salary, address. But as part of bonus, I have added one more column. As part of gross salary to calculate, I have added these 2 column value, and obviously I got the final this column value. Now I have total, instead of 4, it will be 1, 2, 3, 4, 5, 6. 6 different column value. Guys, think about it in the real time. I have taken 4 row just to explain you. On the real time, it will be lakhs of row, 10 lakhs, 20 lakhs. Are you getting my point? Now, whenever you are storing this data, it occupies certain memory or not. Now, what are the memory? For example, the memory occupied by only 4. Let's say, for example, that is, let's say 4 GB. Now you have added another 2. Now it becomes 10 GB. 10 GB update. Now, whenever you want to store all the all the six related column data, it occupies 10 GB data. But I don't want to waste my memory because my manager will come and tell, hey, initially the same file was taking 4 GB of data. All of a sudden, how 6 GB increases? Then I will tell, sir, I have added a bonus and gross salary to extra column. That's why it's added. Then he told, no, it's a memory issue. Because whenever we are storing the data, either we are using a cloud environment or any platform, company have to pay them. Company has to pay them to cloud environment, maybe Amazon S3 or Azure Cloud or Google Cloud and all. So this is not a cost effective. Manager will always tell you, no, we have to keep always in the mind as a senior resource. We should not spend much amount of time, much amount of cost. Are you getting my point? So what will do? Manager will suggest, no, whether even though you are adding to column, try to manage the memory within that range, maybe 4 or maximum 1 GB. We can increase 5 GB or 6 GB, but not like 10 GB, 15 GB and all. Getting my point? So what I'll do? Then the solution is, guys, as I told you, multicollinearity. Second one. What is telling? Guys, if I tell gross salary only one column, do you know this gross salary I am calculating on top of each salary and bonus? For example, each salary is nothing but my base salary, and this is something bonus, right? So if I'm adding each salary plus bonus to gross salary, then I no need to save these two columns separately because anyhow I need only the total amount of salary, that is gross salary. If gross salary I know for a particular employee, that is XYZ, is 1250, is it required for me to know what is each salary and bonus? No, because I am requiring only this. Then I no need to carry forward these two columns in the further analysis. What I'll do, I'll drop it. Then I can modify and restructure this table to this one. So obviously my employee ID will be there, no doubt. My employee name will be there, no doubt. So I will not take e-salary. I can leave it now. Address is required. Where is staying? Address is required. Now directly I take gross salary. Gross salary. Now tell me, guys. So for example, same row, 1, 2, 3, 4. So let's say value I'm taking the different color. 1, 2, 3, 4. X, Y, Z, A, B, C, P, Q, R, M, N, O. Address: Bangalore, Chennai, Hyderabad, Delhi. Now tell me, this is 1250, 2300, 2300, 2900, and 3500. Clear, guys? Now, guys, tell me, do you think that I'm losing any information? No. I'm capturing all the information. Employee ID is captured, employee name captured, address captured, gross salary I'm putting, which is a combination of nothing but which is a combination of e-sal plus bonus. So now tell me how many column related data I'm storing? 4 column related data. So how much memory it will occupy? No doubt 4 GB. What was it just storing just to occupy only this 4 column related data? Now I save 6 GB or not. So now this is the optimized way. Even though I'm calculating, even though it's required to add two different columns, but when further analysis, I don't need to carry forward these two columns because I know these two column value is present in this cross column. Getting my point? So these are the things I need to take care. Now, what is the third point? Because 3 points were there. He's telling conversation. So basically, that comes under categorical, one. That is comes under deal with the categorical variable. The third point of the multicollinearity is nothing but is the fourth point. That is deal with the categorical variable. Let me explain that so we can cover all the 4 points. Okay, deal with categorical variable. I think, right? Yeah, that a variable or value. I think value. That's fine. Variable. Okay, guys. Now, this is also one of the optimized way. These are the real time, whatever things I'm explaining, these are things we are implementing in the real time. I mean, it's not a bookish knowledge at all. Now, again, my manager will come. For example, let's say I forget. For example, in the source system itself, there's another column called gender. Okay, so instead of five, let's say let me add here. Five, not an issue. Let me take another one, not an issue. Same thing I'm taking. Let's say to make it easy, EMPID, or let me add it here so that it will better for understand. Think about I added here. Let's say gender. When I add gender, for example, this XY, this is like female, this is my male, this is my male, and this is female. Now, when I add a extra column, I'm writing a string value, all of a sudden this increases to, let's say, 7 GB. That's fine because I have to add the new column, right? I cannot do anything with this. Then again, my manager will come, hey, no. I mean, again, 3 GB increase. 3 GB, I mean, guys, I'm just explaining 3 GB because four column, four row I have taken. Think about real time. 10 lakhs records are there. If you add a one column and all the value, it will increase like 4 GB to, for example, let's say 50 GB. Are you getting my point? So, increasing 4 GB to 50 GB is not acceptable at all. Think about that. For example, let's say it increases to 9 GB. Then again, my manager told, no. This is not acceptable. If you add a new column which is relevant, right, I should have to identify the gender is male, female or not, that's fine. But 9 GB is not acceptable. Like 5 GB I'm increasing. No. You have to manage within, let's say, 5 GB, 6 GB around. Let's say 2 GB also increase, it will be 6 GB. That's fine. But don't increase up to 9 GB, 10 GB, 15 GB. Then what is the optimum solution? The optimum solution is, guys, I have to convert this categorical value into numerical platform. That will go. Before that, I can use different shortcut. What is that? There's something called, I can consider the notation saying that for female, I will use F. For male, I will use M. Now, guys, you know, for each and every character letter that I'm storing, for that also we occupy the memory. You know, right, from the childhood. Like integer value, 4 byte, floating point, let's say 8 byte, string value, something like that. So each and every character. Now I'm storing here 6 character in a particular one, 4 character. But here I'm just storing one character. Now see, now it looks like very beautiful things, guys. EMP name, let's say for example, then address. Okay, then I think gross salary, right? Yeah. Gross salary. Then I will add here like what else? Gender. 1, 2, 3. 1, 2, 3, 4. Okay, then XYZ, ABC, PQR, MNO. Now BCHD, 1250, 2300, 2900, 3500. Now instead of female, I can put female. Sorry, F. Now male M. Now M. Now F. Now guys see. Now if I write like this, guys, my memory will decrease from 9 GB to, let's say, 7 GB or 7 GB, or like let's say 6 GB. Makes sense? Good. Since my manager will be happy, then he will give a thanks to me. Okay, that's great because it is somehow Allah. But guys, I don't want to stop here. I have to go extra mile ahead so that my manager will give appreciation. How to distinguish, how to become unique in the industry. This thing anybody can do. Okay, manager happy, okay, fine, they will stop here. No. But I will not stop my R&D here. What I'll do, I'll go one step ahead. That I am going to implement, deal with the categorical value. As you know, integer, general integer, you can even Google it out. Integer contains very less memory. For example, 4 byte. 4 byte. I'm just writing example. But when I'm writing string or a character, string, it contains little bit higher memory. Think about, let's say this is contains 6 GB. Now, is there any way I can convert this categorical value or character value or string value to integer value? Happily, is there? Because I know my gender is of two types, either male or female. So can I write, or maybe three types is bisexual and all that is fine, different category altogether. Can I modify this value to my integer value? Yes, I can do. What I'll do? I'll consider my female, let's say female as 0. Then obviously the male will be the opposite to 1. 1. You can ask me, sir, suppose that is bisexual. I mean, another category, for example, P. Then for that, I'll put English value like 2. That's fine. But in our category is not there. Let me remove it. So either 0 or 1. Now I can redefine this table or structure to this one. That is EMPID, e-name, address, gross salary, then let's say gender. Same value. 1, 2, 3, 4, XYZ, like that. Then after XYZ, ABC, PQR, MNO, right? Bangalore, Chennai, what else? Hyderabad, Delhi, right? So this is 1250, 2300, 2300, 2900, okay, 2900, 3500. Okay, now tell me gender. Instead of gender, what I'll do, I'll put female as 0, male as 1, 1 again 0. Getting my point? Now with this, guys, I am reducing my memory from 6 GB to, let's say, 4.5 GB. Now this is the appreciation. You say welcome, or I can say excellent mail will come. Okay, appreciate. You will get promoted. Are you getting my point? This thing no one will tell. You have to implement by your own. This is kind of one step ahead to make it useful. That you are unique in the team. You are doing something wonder which other people are not able to do. So think in that perspective. Just to complete the task is not enough. You have to work in an optimized way. So that now, initially, whatever the memory to document 4 GB, I am doing a lot of hangama. I'm adding 2 different columns, then again another column, 3 different columns I'm adding. But again, I'm managing the volume which is just 0.5 increase. That's all. Excellent. 3 column I'm adding, 3 different column value, but just matter of 0.5 GB I'm increasing from the original memory, because original memory occupies just 4 GB. I'm not considering 9 GB, 10 GB and all. That's the beauty of optimization. Clear, guys? Any doubt so far? Any doubt so far? Yeah. So all of it clear? Like any doubt? Any doubt so far for this? It's very interesting and it's real time actually. Fine. So with this, we have implemented all the different multicollinearity and how to deal with the categorical variable. Okay. Now the next important concept is as a feature selection. Feature selection. Again, I told you. So part of feature selection already implemented. This is just related to multicollinearity, depends upon like p value and all. Okay, depends upon p value. I'll decide which feature selection means feature means what, the column. Let's say I have 40 columns are there. Which column I need to select out of 40 columns? Let's say out of 40 columns, 10 to 12 columns are important for my further analysis, not all the column. Then which 10 to 12 column I need to select? It's not like that a random level select. No, based upon certain criteria. What is the criteria? What is the p value? If p value is less than 0.05, then it is having more significant. If it is less than 0.05, it has having less significant. Okay, let me just write down feature selection. Feature selection. if my p-value is less than equal to 0.05 is more significant. More significant. That column having more significant towards target variable. If it is less than like p-value greater than 0.05, less significant. Towards target values. Clear, guys? That's all about feature selection and all. Now, going to the next, that is reading and understanding the data. Very, very important. Then we'll go for data preparation. Okay, reading and understanding the data. Okay, reading and understanding the data. Okay, guys, there are certain steps are there which is part of machine learning life cycle or data science library. What is those? So first one is, let me write down ML life cycle. The first one is data extraction, or I can say data gathering. Second one is data pre-processing. Third one is data wrangling. Wrangling. Fourth one is model training. I will train the model. Model testing. Sorry. Model testing. Then sixth one is model deployment. Okay. Now let me give a clear-cut idea what is our responsibility and what exactly we are doing in the real time. Model deployment, the person who is doing the model deployment, that is a separate team for that. That is taking care by, there is a separate job profile that is called MLOps, MLOps. You might have heard all this name, not a big deal. Machine learning operation, like DevOps you have heard, right? Maybe somewhere it's written in the, maybe while walking on the road, where tech institute are there, you might have seen, okay, DevOps, then so blah 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 things are there. Similarly, there is something called MLOps. It's a combination of two different words, that is ML, that is machine learning, ML, plus ops, OPS. What is ML? ML stands for, as I told you, machine learning. MACHIN, machine learning. Like whatever we are learning now. Then there is another team, operation team. Okay, ops stand for operation. Operation means basically operation. Yeah. Basically taking care of all the deployment kind of things. So that is a work of a ML ops team. Now, data extraction, data pre-processing, that is a work of basically a data engineering team. In short, we are writing T. That is data engineering team. Data engineering team. Okay, guys, I'm just explaining different job profile. What is the responsibility and all? It's not like that you have to take care of everything. Okay, if you join in a startup, small organization where only 5-10 people are there, then you are the one man army. You are the kind of CEO. You are the sweeper. Okay, you are the you have to receive the call. You have to reply like you are the receptionist and all. Everything you will take care. Okay, you are the office boy. Okay, everything you will take care. But generally in the MNC or like a big organization, there is separate teams or departments are there. You don't need to involve in each and every department. Getting my point? Yeah. So this is data engineering team. Now what's about data wrangling? Data wrangling is a wide perspective. It's a part of data scientist obviously. So these three things you have to take care. It's a part of data scientist or MLE, machine learning engineer. Like whatever we are learning, MLE, machine learning engineer. Okay. Machine learning, or I can say let me write on DS, data scientist specifically. Okay, machine learning engineer, or I can say data scientist. Data scientist. Getting a point, guys. So data wrangling is a wide area. So data wrangling comes under data wrangling. Data wrangling it contains data cleaning, data mining, data crunching, and a lot many things. Then feature engineering. Then we have something called feature selection. Today we have seen, right? Feature selection and all. And why aspect. Lot of things are there. So typically speaking, your work starts from here. But let's see, today we are able to see reading and understanding the data. But try to understand, let's say from data engineering perspective. Whenever they extract the data, they gather the data, what will they do? First, they have to go for data pre-processing. Pre-processing in the sense, like as I told you, let's say while extracting, 100 columns are there. Do you think that all the 100 columns are required for it? No. Unnecessary column you have to drop. That is a false filtration that the engineering team will do based upon their domain knowledge. I'm not talking about this p-value and all. P-value and all. This thing you will implement here in this case. Feature selection, data wrangling. But before feature selection also, that is another pre-processing activity. For example, any null value is there. They have to handle the null value. Any missing value is there. They have to fill the missing value or not. Now, sometimes if you join in product-based company also, they will also tell, okay, please take care of all the things. I mean, kind of end-to-end data scientist, call full stack data scientist. I mean, you have to do data engineering stuff, you have to do data scientist stuff, even if you have to take care of the deployment part also. You are the one man army, as I told you. You have to you have to do everything, all the stuff that I have mentioned here. But if you join in some big organization, there is a dedicated and very confined way assignment. No, you just have to take care of the model training and model testing, which we are doing as part of our class. In the last class also, right? We are creating the object for training. Linear regression. We are using fit method to train it. Then once trained, we have to test it. Means we have to predict. You have to evaluate the value. That's all. Once it's done, then the model deployment part will be taken care by the different team that is called MLOps. MLOps. Clear? That is a typical life cycle. Now, as we actually reading and understanding, first you have to read it, you have to discuss. Because you don't have domain knowledge, sir. How do I get that domain knowledge? That is a separate team in the each and every organization that is called BA. BA stands for business analyst. Business analyst. So what is their work? These are the intermediator between your client and your tech people. Tech people means you people. Tech people, listen, technical people, tech team. So you can go ahead and directly interact with client. There is a bridge or mediator between client and because they are non-technical fellow and they have good business domain knowledge. For example, you are working on BFSI domain or the e-commerce domain or travel or insurance, whatever may be, out there energy generation. They have domain knowledge, good domain knowledge. So they will interact with client. What is your requirement? Client will okay, I need this feature. There should be a submit button. There will be a right corner. There should be some star mark. Blah blah blah. Something. All the requirement gathering will be taken care by the BA. Then BA is our internal company team only. So internal discussion will happens with the tech team. Very not formal discussion. I mean just informal also fine. Okay, okay, for boss. Let's say I'll pick some name. Priyadarsini or some Ritas or something. Okay, client is telling we have to develop this model by using linear regression. It's multiple linear regression. Okay, sir, fine. So these are the feature you have to enable. Okay, fine. Sir, you have to in the Angular just UI you have to create a submit button. You should have two test box which will take username password or XYZ. Everything requirement gathering will happen and that they will convey to BA. Then again, as part of this discussion, maybe you will raise some query, means technical question. Obviously, those people are not technical, they cannot give the answer. Then again, they will go back to client and ask, okay, sir, we have some technical question which our tech team is asking, could you please clarify this? Then client will tell, okay, this one. Then again, client will reply. Then business BA team will go and pass to you. Okay, so this is the answer for your query. Any other doubt? Then again, tech team will, okay, this more few doubt. Then again, they will go back. So this is a kind of infinite loop. It will go. Kind of infinite. You might have seen such type of diagram in the internet for the DevOps. Okay, so they will take the requirement gathering, they will pass to you, you will ask some doubt, again they will take care. So this is the intermediate work of a BA, business analyst. They will help you to understand the data, okay, and reading the data care. What is required, what is client requirement, what you want to develop, each and everything they will ask you or clarify you. Okay, clear? Any doubt so far, guys? Any doubt so far? Guys, whatever I'm explaining today, I mean, not only today in all my classes, not like just for bookish knowledge. These all are coming by experience as I'm working in the industry. So these are very important. Whenever you will join the organization after completion of the course, I mean, your BTech or whatever you are doing, like so you'll see or you will get to know all this stuff. So at that time you will feel very comfortable. Okay, sir had taught to us in the semester exam. We know. It's not like that. I just explaining all these things and I leave it. Okay, no, good. Because after you, this is fine. But I'm still showing some extra thing. How in the industry people are working. These are the steps you need to follow. That's how the process of the methodology they are following. You cannot go ahead. You don't know. But again, there's always a corner cases. If you join an organization as a total startup, where only 5 people are there, then you are the BA. Getting my point? You are the tech team, you are the CEO, you are the CTO, you are the BA, you are the sweeper, you are the office guy, you are everything. One man army, as I told you, you have to take care of everything. But generally, I'm just doing the best practice, what industry follow. So there is a separate team called BA, business analyst team. There is a separate team called data engineering team. There is a separate team called data analyst team, data scientist team. There are MLOps team, testing team, developer team, architect team, delivery manager. Lot of things are there. Getting my point? So let me go. And next, data pre-processing, as I told you. Pre-processing also I will completed. Like part of what they will do part of this. So basically they will do handle missing value, data type data type conversion, data type conversion, then handling missing value, null value, okay, null value, okay, each and everything they will do. Dropping unwanted column, dropping unwanted column. When I'm telling dropping unwanted column, it's not like the same as like we were using p value because there's a data engineering team. They don't know what is p value. This is pre one. For example, 100 column. So business analyst team will tell, hey, this column unnecessary, drop it. Just based upon their domain knowledge, they will drop it. But whatever I have explained p value, that depends upon data scientist knowledge. which is important. Let's say out of 100, they drop 60 columns. Now 40 columns is there. Now out of 40 columns, which 10 column or 12 column are more important or 20 columns are more important? How to figure it out? For that you have to use p-value. But you are not using p-value here to drop here. No, no, no. It's just domain knowledge. Because whenever we are storing the data is a kind of raw data, not a structured data. Unnecessary things will be there. For example, in the employee, there should be something like that. Think about, let's say they are, what else I can say? I mean, let's say phone number, or like zip code, or their family members, or how many members are there. I mean, that is not required for me. For me, if required, then I'll consider. Then whether it's required or not, that depends upon the scenario. That business team or client will rectify me or clarify me. Are you getting my point? Now, the initial steps, which I already explained, but let me go through one more time. Initial steps. Okay, that's fine. So let me go to my PPT again. I hope till this you are clear. So I've written all these steps in my whiteboard, right? So these are the typical mainly 6 steps involved in machine learning life cycle. This is very, very important, guys. These are the same steps we do follow in the real-time industry. First, data collection or data wrangling. Sorry, data extraction or data gathering. Then data preparation or means pre-processing. Then data wrangling, which includes a wide perspective like data cleaning, data mining, feature engineering, feature selection, blah blah blah, lot of things. Then training the model, model training. Then test the model, model testing. Then model deployment. I and not only that, in addition to that, I have also explained which teams are responsible to take care of all these things individually, right? It's not like they're part of one single team, they will do all the 6 steps. No. But exceptions are always there, as I told you. For example, you join a small company where only 5 people are there, 10 people are there. Then you may be involved in all the steps. That is a different case. But generally, typically speaking, there are different teams are there to take care of these different steps. Not it's not one team work. I hope now we are clear. Okay. Now move to our PPT that is initial. Now you can see, guys. So generally, what happens if my data, I mean value of the column is too big or too high, then if I have to represent in the diagram like 2D axis, or I have to go for further analysis, then I may get some inaccurate output or printed output. For that, I have to bring back the range within the certain range. For that, I am using some different normalization or standardization technique. For that, there is a class called min max scalar, standard scalar. Okay, that we are using as part of that is a kind of improvisation step. Okay, of my machine learning algorithm. Then I will split the data into train test split as I have explained in the last class. But anyhow, I'll just give a quick recap. Then what happens? Once my test data, training data, validation data is ready, then on top of training data, I'll train the model or build the models, which is the next step, that is building the model. I'll explain. Okay. Once I build the model, okay, then I'll go for testing the model, obviously. Okay, testing the model. Okay, I'll test the model. Then whether the model is being best accuracy or not, that I have to validate on top of validation data. Then I will go ahead and deploy the models. Now you can see the same thing is written here, p-value and all. There's another factor called VIF. I don't want to make it complex because that is again a advanced technique. But if you stick with p-value, that's enough. Because how p-value also consider that is something called VIF. Okay, variable inflection factor, something like that. Okay, if I will do that, also by using this, I can decide which column is important, which column I need to keep, which column I need to drop. Same as p-value. Okay, that's why I don't want to tell the two different things to make it confused. Okay, fine. Now let's me come back to my whiteboard. I'll explain. Then we'll go to the real time practical implementation and all. Fine. So let me come back to my whiteboard. Let's see, guys. So initial steps completed. Now we are building a model. So let me do in such steps also, like what we have explained in the last class. Fine, guys. I know whenever my data set is ready, like I do follow all the steps. Okay, now data wrangling and all up to this point, my data set is ready. So I'll get the data set, like as I explained in the last class. For example, this is my data set, which contains 1000 records. It's a clean data, right? Clean data, which is ready for model building. Then what I'll do? Do you think that I'll go ahead and implement machine learning technique on top of this entire 1000 record? No. I need to split the data into, typically people are telling two different category, but as for industry standard, we divide into three different categories. One is training data, as I have explained in the last class, right? Training data set, that is testing data set, another one is called validation data set. Somebody has asked me in the last class, I think Priyadarshini, okay, sir, why we use validation data set? In your class, I think, or some other batches, I don't remember, but yeah, last time somebody has asked. So I have also explained clearly why we use validation data set. Generally, we use training data set to train the model, basically model training or model building. Let me use a different color. Model training. Model training. Model training, or you can say model building. All are same. BUILD. Model. Now, once you build the model, whether your model is perfectly fine, working fine or not, you have to test it, right? So basically, you have to test it, test the model. So model testing, model test. Model testing means you have to predict the value, okay, prediction you are doing. So whatever the prediction you are doing, for example, you got some accuracy, let's say 89% accuracy. Is there a chance that you can increase this accuracy from 89 to let's say 97%? Are you thinking like that? If you, because you will get to know by the time you work, you will get to know, yeah, because I have the balanced data set, I have sufficient data, I am expecting at least more than 95, 93%. What is giving less? Then you will implement different type of hyperparameter, hyperparameter to improve the accuracy from 89 to 97%. Now you have implemented. Now once you implemented, you have to validate now whether really the accuracy increase or it just remains same as 89 previously. Now you have to validate on top of what? Validation data set. So basically, validate the model. Validate the model accuracy. Accuracy. Right? Whether really it improved from 89 to 97, or if not 97, at least 95 or 96, whatever it may be, 96%. That you need to validate. So that's why we are taking a separate example validation data set. And you know, as per industry standard or researcher or scientist, they are given a beautiful ratio how to split. It's not like that you have to split. And yeah, one more thing I should not forget. For that, we are using a beautiful method, that is train. You might have observed train underscore test underscore split method. This is a method, is PLIT. We are passing inside this. We are passing x train. Sorry, a total value, not x train. Okay, it created different category. Okay, on which ratio? Generally, it is 70 is to 20, 30 ratio. But as I am taking a validation, so it will be 70 is to 20 is to 10 ratio. As you are taking three different categories. But generally in the production environment, real time you are using. But if you are doing POC, start of your project, generally there is no point of validation. So you can consider 70 to 30. So at that time, you just have to take only two different categories, training and test. So you can combine this 20 and 10, right? It will come in 30. Clear? This thing we have explained in the last class. This is a part of initial step. Now, my data set is ready. Then what to do? Second one, next step is model building. Building the model. Okay, so how to do that? As you know, model building. I hope till this point no doubt, guys. I'm going step by step, guys. Model As part of model building, as you know, very simple, two different steps, just two steps I have to do. What are those steps? First one is like I have to create the object of the linear regression. REG is equal to linear regression because we are learning here linear regression, right? That's why I'm using creating the object of linear regression. In case of logistic regression, you have to create the object of logistic regression or not. Get my point? Then we have to train model building REG dot. There is a method called fit or fit underscore transform. Then you have to just write X train and Y train value. That's all. Your model building completed. Once the model building complete, then you have to predict, as you know. REG dot predict. Last class we have seen PREDICT predict. In which value you have to predict? For example, that value you have to pass. Last class we have passed the area. Now in today's class I will pass three different things. Area, number of BHK, right? Area, number of BHK, and how old that particular house. Three different parameters to pass. Okay, so it will give me print. It will give me the value. Once the value I will get, that I need to validate, or basically I need to prove it whether the value that I have get by using the machine learning algorithm that is correct or not. By using coefficient and intercept, that we'll see one by one. Let's enter into the practical hands. Fine. Now, let me go to enter into practical hands-on, that is multiple linear regression. We'll see all the formula, loading the house, model training. Okay, till this point we'll see. Okay, so let me go to the formula. I have already completed, just in the slide I will show you each and every. Multiple linear regression formula. In short, I am writing MLR. Okay, you should not forget after 1 month what is MLR. Okay, let me go back to my same things I have explained start of my class or not. I have already explained all these things in a whiteboard in a neat and clean way. So generally, the equation of the straight line for simple linear regression is equal to y is equal to mx plus. But if it's a multiple linear regression, then instead of mx, I will write m1x1 plus m2x2 plus m3x3 plus c. Here it is taking b, same, nothing, just a constant value. Now, I need to set a real-time problem into the formula. What is the problem? Now see, the data set is given here. You might have observed, if you are able to recall, in the previous classes I have taken only area, this column, and a price. Price depends upon area. In the simple linear regression, there is one feature value. But here I have three different feature value. Area, number of bedroom, age of the particular house. So now the price does not depend upon only area, but also it depends upon bedroom as well as age. Are you getting my point? So similarly, it's something like for 2,600 square feet area, if bedroom is 3 and age is 20, this is the value. If it is 4,000, bedroom is 5 and age is 8, then this is the value. So I've taken some sample data, but not like that in the real time you have only 4 to 5 data, right? Lakhs of data are there. So once data you have considered, now you can see area, bedroom and age and price. I fit into the mathematical equation, that is y is nothing but my price, which I need to predict my dependent variable is equal to m1 into area, that is independent variable, plus m2 into bedroom, independent variable, plus m3 into age, independent variable. Here also I written clearly. See how beautifully I have designed this content also for your better understanding. See, price is a dependent variable. All these things, area, bedroom, and independent variable, which is nothing but we call it feature. Last class I have explained all the terminology, right? Feature, prediction, target, and all, right? If you are absent, then I'm sorry. Maybe everything going over your head, right? I hope nobody is absent because I'm seeing the same number of consistent number of students, 60, 56, something like that. Now, M1, M2, M3 is nothing but coefficient. So the other name of slope is coefficient or a gradient and all we have seen. Now B is nothing but my intercept that you know from a childhood. Now Y is equal to this one. Final. Right? Now let's go back. I have taken a data set, like how I have taken in the home price one.csv file. Lot of data are there, maybe 20,000, 30,000, 50,000. Just some sample data, 5 to 6 row I have taken, which contain the same area, bedroom, age, and price. Now, what I'll do, guys, I'm just reading and creating a data frame. How to do that? And for that, I'm using a Panda data frame. What is Pandas? That I have explained in the last class. Pandas, NumPy, Matplotlib, these are the different library given by the Python. So basically, Pandas is used for analytics purpose. Similarly, Matplotlib and c₁ used for visualization purpose. NumPy is used for mathematical operation. Okay. Now, what I'm doing here, see, I'm just splitting. I mean, obviously, I'm just creating two different variables. Now, see, model training. I'm creating the object of linear regression. I'm the creating the object of linear regression. What is linear underscore model here? The sklearn.linear underscore model, that is a package basically where linear class is present. So that's why I'm using linear underscore model dot linear regression. Fully package name. So package name dot class name. If it's present in the same, then no need to use it. Now my model train is ready. Now I have to fit it. What to fit? Extrain. What is extrain? Extrain and white train. White train nothing but independent variable, that is df dot price. What is extrain? Except price, all other value, that is area, number square, this one. That's area, bedroom, and age. Now my df contains all this. If I drop price, then it will contain only these three. So I will have to write df dot drop of price. Same thing I will written. See, try to understand the code. Df dot drop of price. If I drop the price, then it will contain only area, bedroom, and age, which is nothing but my x train. Then comma df dot price is y train. And my model is train. It's ready. Clear, guys? Any doubts so far? Any doubts so far? Now, what happens, guys? See. Okay, it's finding intercept. I'll come to intercept later. Now, let's see what is prediction. See. So same things. 1, 2, 3, 4, 5, 6. Past 6, 7 lines are same. Now focus on this. RG dot predict. Now how many value I'm passing? 3. In my last class, I was passing only 1. That's area. That is 3,300 if I'm not wrong. Here I'm passing 3,000. It's okay. Now, in addition to 3,000, that is square feet area, I'm passing number of bedroom as well as years. How old that particular home is. Now you can see it's giving me the output 498,408.25158.031. Clear, guys? Any doubts so far? Now let me ping this value in the chat box. Now the time has come to prove it. I will prove it whether it's matching or not. Okay, so let me go back to your chat and ping this value. Okay, this is the value that my model has predicted, right? My model has predicted. That means this value I'm getting according to machine learning algorithm. Let me scroll down. My machine learning algorithm, okay. ML algorithm or machine learning model, I guess. My machine learning model predicted the value. Predicted a value is nothing but whatever I written, like 498,408.15. Sorry, 2515803. 25158031, something like this in lakhs. Okay, this is the predicted value that I figure it out by my machine learning model. But guys, think about, for example, you are going to purchase a house. So builder told you this price. Do you think that you will believe blindly and you give the same amount, transfer the amount without thinking, without taking a single minute? No. He may. How do you verify whether the amount whatever he told is a correct value or wrong value? For that, we are using the proof method, like same things I have done in the last class. Also, two different Brahmastra, that is intercept and M. Intercept is nothing but my C value. M coefficient is nothing but my M value, or I can say slope value, right? This is my slope. This is my intercept or y-intercept, I can say. Got it? Now how to find that? Now finding. So basically I have to prove it, right? Finding value of slow intercept and coefficient. So as you know already, always we use the Brahmastra, that is this object, because this object plays a vital role. On top of this object, we are training it, we are predicting it. Now we will find the value of REG also. So now REG dot COEF coefficient print. Just one line of code I have to write. So it will give me the value of all the coefficient value and intercept dot intercept. I think so, somewhere I've written in today's class also. I'm able to recall. So this is my, it will give me three coefficient value, M1, M2, M3. And this is, will give me my C value. Now what I'll do, I'll put in the equation. Okay, I think I've written in my today's class somewhere. Let me see. Where I've written, yes, I've written here already. Okay. Now I'll put in the same equation. What is the equation? This one. Price is called M1 area, M2 number of BHK, M3 this one plus 2. So let me write down the same thing. Okay. So I just have to put the value only. Okay. So price is equal to M1 into area plus M2 into what is that? Number of BHK or bedroom, I guess. Number of bedroom BHK plus M3 into age, means how old that house is, age, plus C. Now I'll figure it out the value of M1, M2, M3 and C. And I know this value. So this area is nothing but is giving 3000. Right? This number of BHK is giving 3 BHK. And what is the age? I think 40 if I'm not wrong. Then if I put all other value plus, obviously M2 value, then plus M3 value, then plus C, then happily I can get the value of price or not. Value of price or not. Now let's see how we are calculating. I mean, obviously we know how to calculate the C. What is the value I am getting? Then I will put it. Then we will prove it whether this value is matching with this value or not. This value or not. That is our intention. That's, if I do that, then happily I can say it's 100% proof. 100% proof I can say it's correct matching. Okay, and my model is giving 100% accuracy. Okay, let me do this. Then lastly I will prove it. Fine. Okay, let me go back to my again PPT. I will show you how to find this value. I'm calculating. Okay, this thing we have seen, right? This value we are getting. So let's one step back, one step back. Here you can see same things. First 1, 2, 3, 4, 5, 6. 6 line you can remove, including including this one. Obviously 8 line you can. 2, 4, 6, 8, 9, 9 line. Now it's just one line I have written. REG dot intercept means this is C value. So how much is giving? 21323 dot 001865404008. Okay, this is the intercept value. Anybody could ping on the chat box, otherwise I have to ping. Just ping on the chat box this value. Fine. Now how to find the M value? You can see same, first 9 lines are same, just REG dot coefficient. Guys, see here I'm trying to find out 3 different values. See 119.062444194. Then there is a space, means it's M2 value. 23388 dot 8007794. Then space, then minus something. See M3 value. So first one is M1 value, then M2 value, then M3 value. 3 different value it has given to you. Now what I'll do? I'll put this value. In this equation. I have done also. See, y is equal to mx plus 3. So this is my M1 into that is 3000 square feet plus M2 into 3 bedroom plus M3 is nothing but minus something value into 4 plus beta value. So beta in the sense C value, that is intercept value. Now how much I am getting? This much getting. But I have written here. You may not believe me. Maybe Sarah has edit and written. Let me do practically use your calculator and see whether the same value we are getting or not. Okay, let's come back to our whiteboard again. So how much is coming? Let me see. 34. Yeah, that's fine. Okay. So let me come back to my white. All of you, please open your calculator. 062 441 44194. If I'm not wrong, 441 Fantastic. So this is my M. This is multiplication, right? This is faster into M2. M2 is how much? 23388. 23388 dot 23388 dot 8800 8800. Guys, meantime just multiply it and ping on the chat box so that we can save the time. Do it fast. 23388 dot 8800 7794 7794 into 3, right? So this is my second term. Now plus third. What is M3 value? M3 is nothing but, do it fast guys, minus 3231 dot 3231 dot 7179 7179 7179 0683, right? Let me cross check. 0863. Sorry, 0863. Okay, this is dot guys, this is not minus, this is dot. Okay, into how much? That is 40 plus C value. What is C value? Do it fast guys. 221 323 dot 00186 00186 540 540 540 408 408. Guys, quickly tell me what is the, I mean, just one by one. But if you multiply how much, then this one. Do one by one, then I will do calculation. Let me see your chat box. I will not do this. Use your calculator, do it fast. Any doubt so far? Now as the value, both value are matching. Okay, whatever you people are calculating, I have written here. Okay. Fine, so this value is nothing but this one. This value is nothing but this one. And this value is nothing but this one. Okay, I put the value and it is perfectly matching. Now I can say the model prediction value is 100% accurate. Clear?